Welcome to the Deep Dive. We're the show that digs through stacks of sources to pull out the real gems, basically giving you a shortcut to getting seriously well-informed on important topics. Today, we're diving into something that's, well, it's not just tech infrastructure anymore. It's really the heart of modern business. We're talking about data. Data isn't just part of the business these days. You could argue it is the business. It's a strategic asset. It's your competitive edge. It's the intelligence behind decisions. So we're going to peel back the layers on data architecture, data warehousing, try to make it a clear journey from just raw information to maybe your most valuable asset.
Exactly. And that's our mission for you today. There's so much complexity around managing, storing, and actually using the huge amounts of data out there. We want to cut through that. We've looked at a whole range of sources, different perspectives, and we're distilling it down to what you really need to know to understand the shifts happening in this really crucial space.
Okay, so digging in, let's start right at the beginning. This term, data warehouse, we hear it all the time. What exactly is it?
Fundamentally. Right. Well, at its core, a data warehouse is a centralized repository. A central place, yeah. It integrates data from potentially many different sources. Think operational systems, maybe external databases, web services, that kind of thing. But here's the main thing. Its job isn't really day-to-day transactions, not like your order system. Instead, it's built to give you a consistent, consolidated view of data over time. So, historical data. And it's specifically optimized for analysis and reporting.
Okay, so consistency, history, analysis focus.
Precisely. It's usually organized around business subjects, customers, products, sales. And critically, it's designed not to overwrite old data. Keeps that history. It's like a persistent memory for the business. And typically, you'll find key components, the source systems where data comes from, ETL processes, that's extract, transform, load the warehouse itself, maybe smaller, focused data marts, and then the tools people use to actually get at the data.
That idea of a memory center for the business, I like that. Some sources really frame it that way. How does that specific center fit into the bigger picture, the whole data architecture concept?
Yeah, that's a really important distinction. So if the data warehouse is like that specialized memory center, then data architecture is the entire blueprint, the overall structured design for how an organization manages all its data assets. It covers the systems, yeah, but also the policies, the standards, basically governing everything from how data is collected and stored right through to how it's integrated and used. And the key goal is aligning all of that with the business's strategic objectives. It's not just tech for tech's sake. And it's definitely not one size fits all. It has to grow out of what the business actually needs.
Okay, that makes sense. Blueprint versus the specific room, kind of.
Yeah.
So what's changed? Why is having this solid architecture gone from being maybe a nice-to-have competitive edge to something businesses almost need today?
You've really hit on something fundamental there. A few years back, yeah, a good data setup was maybe a leg up on the competition. Today, it feels much more foundational, table stakes almost. Several things are driving it. One is just the sheer volume of data. It's exploding. Then there's the need for a single unified view across all these different, often disconnected systems. Businesses are desperate for that. And of course, the demand for data-driven decision-making. It's undeniable now. So good data architecture, it gives you better data governance, better compliance. It gives you scalability to handle that growth. It lets you integrate data smoothly. And ultimately, that means, hopefully, more informed decisions, better customer experiences. But let's be real, it's an investment. There's the financial cost, sure, but also the complexity to build and run it and the whole change management piece for the organization. Yeah, that's often the hardest part.
Right, the human element. So if we're building this crucial blueprint, this architecture, what are the absolute core principles, the non-negotiables that make it robust and effective?
Yeah, when you boil it down, there are definitely some key guiding principles for a strong data foundation. First up has to be data quality. And this isn't just, fixing typos. It means the data is clean, it's accurate, and it's genuinely fit for whatever purpose you need it for. Because fundamentally, if your data is wrong, any analysis, any decision based on it, it's flawed from the start. So it means things like continuous monitoring, using automated tools to spot problems early.
Okay, quality first. Makes sense. What else?
Next, data governance. Think of this as the rule book, the framework that defines who owns the data, who's responsible for it, who can access it, what the processes are for managing it consistently and responsibly. It's vital for things like compliance, mitigating risks, just making sure everyone knows the rules and there's accountability.
Got it. The rules of the road for data.
Exactly. Then there's data provenance, or sometimes called data lineage. This is all about tracking the data's journey. Where did it come from? What transformations happened to it along the way?
Yeah.
It's absolutely critical for building trust in the data, for audits, for figuring out what went wrong if you get unexpected results. You need that transparency.
Like a chain of custody for data.
Kind of, yeah. Then, data in context. This ties into metadata management. Data on its own is just numbers and text, right? It needs context to be meaningful. Metadata, which is data about the data, provides that context. It explains what the data means, how it was generated, any business rules applied to it. It's what makes data discoverable and actually understandable.
Right, the story behind the data.
Precisely. Next is granularity of detail. This is about how detailed the data you capture is. Generally, you want to capture data at the lowest, most atomic level possible. Think individual line items on a receipt, not just the total order amount. Why? Because it gives you maximum flexibility later to aggregate it, slice it, dice it however you need. Of course, there's a trade-off with storage and processing, but starting granular is usually the way to go.
Okay, keep the detail.
Then, absolutely critical, data security. Protecting sensitive information from unauthorized access, from breaches, from threats. This means multiple layers encryption, strong access controls, constantly looking for vulnerabilities.
Non-negotiable, really.
Totally. And related to that is scalability and performance efficiency. Your architecture needs to handle growth, more data, more users, more complex queries, without falling over. This is where cloud platforms really shine, letting you scale resources up or down as needed, often paying only for what you use. Efficiency is key.
Adapting to change.
Yes. And finally, interoperability and usability. You want a consistent experience for users, sure, but also your data systems need to play nicely with other tools, other platforms. Thinking about open interfaces, standard formats. That helps avoid getting locked into one vendor and makes your data more useful long-term.
It's fascinating, actually, how those principles really form the bedrock. Doesn't matter which specific architecture you end up choosing, those seem to apply across the board.
Yeah, you're absolutely right. They are pretty universal foundations.
Which is a good segue, because the way people implement these is definitely changing. The landscape isn't static. What are the different architectural styles or patterns we're seeing companies adopt now? How do they compare?
Yeah, the landscape has definitely evolved beyond just that traditional model. So let's walk through the main ones. We've mentioned the traditional data warehousing architecture.
Yeah.
Its focus was primarily historical, structured data, usually in relational databases, often that three-tier style. ETL, the main warehouse, then maybe smaller data marts for specific departments. It powered BI for decades.
The classic.
The classic. Then, driven by big data, came the data lake architecture. The key difference here is it stores vast amounts of raw data in its native format. Structured, unstructured, semi-structured, doesn't matter. The idea is ingest everything first, then figure out how to process or structure it later when you have a specific need. Great for breaking down silos and enabling things like data science exploration on huge, messy data sets.
So store first, ask questions later, kinda.
Pretty much. Now, connecting this to the bigger picture, one of the really interesting developments is the data lakehouse architecture. This aims to unify the best of the data warehouse and the data lake onto a single platform. The goal is to get the structure and performance benefits of a warehouse for BI, plus the flexibility of a lake for diverse data types and AML workloads. It tries to eliminate that awkward split and simplify the tech stack. Often you see a layered approach, sometimes called multi-hop, maybe an ingest layer with the raw data.
Like the lake?
Exactly. Then a curated layer, sometimes called silver, where data is cleaned, maybe standardized, integrated. Quality improves here. And then a final layer, or gold layer, where you create business-specific data products, optimized views, aggregates. This is often the source of truth for reporting.
Okay, that makes sense. Lakehouse bridging the gap. What else is out there?
Well, a very different philosophy is the data mesh architecture. This is a decentralized approach. Instead of one central data team owning everything, data ownership is pushed out to the individual business domains like marketing, sales, finance. Each domain treats its data as a product that it owns and serves to the rest of the organization. It uses a federated governance model. The goal is really scalability, flexibility, breaking down bottlenecks from a central team. It's quite a paradigm shift.
Decentralized ownership. Interesting. And one more.
The data fabric architecture. This is maybe less about a specific storage pattern and more about creating a unified management layer over whatever data stores you already have. It aims to integrate data across different sources and platforms, your existing warehouse, your lake, Maybe cloud services providing consistent data services like access control or discovery without necessarily moving all the data.
Yeah.
It tries to reduce silos by connecting things intelligently.
So like a smart layer on top of existing investments.
You can think of it that way, yeah. Augmenting rather than replacing.
It definitely sounds like these aren't always isolated choices. Companies might mix and match, right? How do they often fit together in practice?
Oh, absolutely. They often complement each other. Many places end up with a multi-layered approach that borrows ideas from several of these.
Yep.
That medallion architecture concept we touched on with the lake house, bronze, silver, gold layers is a very common pattern for organizing the flow, regardless of the underlying tech. Raw data lands in bronze could be a lake. It gets cleaned and integrated into silver, maybe still in the lake house layer, perhaps more structured. Then it's prepared for consumption in gold. This might look a lot like a traditional star schema in a warehouse or lakehouse query engine. This layering helps manage complexity. You solve different problems at different stages.
Right. Breaking it down. Okay, so we've got the big picture architectures. Now, this is where it gets really interesting for me. How do you actually structure the data inside these things, the modeling? And you can't talk about that without talking about Ralph Kimball. His work seems foundational.
Absolutely. Ralph Kimball's work, especially his book, The Data Warehouse Toolkit from the 90s, really set the standard for analytical data modeling for a long, long time. His main contribution, the star schema, is still incredibly influential. The concept is pretty elegant, actually. You have a central fact table. This holds your core measurements, your events, things like sales transaction amounts, quantities sold, call durations, whatever you're measuring. And surrounding this fact table are several dimension tables. These provide the context, the who, what, where, when, why for those facts. So dimensions for customer, product, date, store location, etc. The grain of the fact table, what each row represents, is super important. Kimball stressed making it as atomic, as low level as possible, like a single line item on a sale, not the whole sale.
Why so granular?
Because it gives you maximum flexibility later. If you store the detail, you can always roll it up. But if you only store the summary, you can never drill back down to the detail you didn't keep. It lets you answer unforeseen questions down the road, like which specific products drove sales during last year's holiday promotion in the Northeast region. You need that granular data connected to all those dimensions. He even strongly advocated for a dedicated date dimension table. Seems simple, but having columns for fiscal quarter, day of the week, holiday indicators, etc., pre-calculated in one place makes querying by time incredibly easy and consistent. His philosophy was really, do the hard work during ETL to structure the data well, so querying it later is fast and simple for business users.
Get the structure right up front for easier analysis later.
Exactly. And his approach was really needed back then. It provided speed to business value because the star schema is inherently much easier for analysts to understand and query than highly normalized structures. And critically, it offered huge performance benefits. Those star joins between a big fact table and smaller dimension tables were much more efficient on the database systems and OLAP cube technologies of the time.
Makes total sense for that era, but how does that star schema compare to other ways of modeling, like really normalized models or something I hear about called beta vault?
Yeah, good question, because they all have their place. Let's compare. Star schema versus normalized models. We touched on this. Normalized models like third normal form, 3NF, were all about minimizing data redundancy and protecting data integrity. Lots of small tables, lots of relationships. Great for operational systems where you're constantly inserting, updating, deleting individual records. But for analysis, joining all those tables back together can get really complex and slow. Star schemas accept some redundancy repeating dimension attributes specifically to simplify queries and boost performance for reporting and BI. So they often play complementary roles. You might see normalized structures in the integration layer, like that silver layer, and then transform into star schemas for the presentation layer, the gold layer, where end users connect.
Okay, different jobs, different structures. What about data vault? It sounds different again.
It is. Data Vault is a hybrid approach. It tries to combine the historical tracking and integration strengths of normalized models with the flexibility needed for warehousing. It's known for being agile and scalable. It has three main building blocks. Hubs, which are unique business keys like customer ID, product code. They just contain the key and maybe some metadata. Very stable. Then links, which represent the relationships or transactions between hubs, like this customer, hub, purchased this product, hub. Links capture the associations. And finally, satellites. These hang off the hubs and links and contain all the descriptive attributes, the customer's name, address, product description, etc. Crucially, satellites track history. When an attribute changes, you add a new satellite record with a timestamp you don't overwrite. Similar in concept to Kimball's slowly changing dimensions type 2, the benefits. It's great for auditability because of that history tracking. It's also designed to be loaded in parallel, which helps with large data volumes. And there's Data Vault 2.0, which explicitly incorporates things like big data platforms, NoSQL, real-time streaming, and often separates the model into a raw vault, tracking source data faithfully, and a business vault, applying business rules and derived logic.
Hubs, links, satellites.
Yeah.
Okay, a different way to piece it together. This brings up a massive question, though. All these modeling concepts, Kimball, even data vault to some extent, they were developed when compute and storage were expensive, right? Infrastructure was the bottleneck. Today, with cloud data warehouses, compute is powerful and relatively cheap. How do these older modeling ideas hold up? Has the hard work shifted?
That is the multi-million-dollar question right now. And yes, it represents a fundamental paradigm shift. You nailed it. Old world, infrastructure is expensive and slow. Human engineering time to optimize complex models is, relatively speaking, cheaper. New world. Cloud infrastructure is powerful, scalable, and comparatively cheap. Good data engineers. Very expensive. This completely flips the optimization equation.
So how does that play out in practice? Give me an example.
Okay, let's take inventory management. In the Kimball era, tracking every single inventory movement and trying to query the current stock level across millions of transactions was often way too slow. So Kimball recommended patterns like inventory snapshot fact tables. Take a picture of stock levels periodically, say daily. That made querying current inventory fast. But today, modern cloud data warehouses using columnar storage and massively parallel processing, MPP, can often scan and aggregate billions of rows of raw transaction data in seconds. So querying the full inventory movement log directly to find the current balance might actually be feasible and fast enough. Building and maintaining that separate snapshot process, that takes significant, expensive engineering effort. Snapshotting becomes an optional optimization you might add later if you hit performance limits, not necessarily the default starting point. It's often cheaper now to throw compute at the raw data than to pay engineers to build complex pre-aggregation pipelines.
Right, leverage the cheap compute instead of expensive human time. What about something like slowly changing dimensions?
Perfect example. Kimball defined SCD types. Type 1, overwrite. Type 2, add new row for history. Type 3, add previous value column. Implementing Type 2 especially often required pretty complex ETL logic to manage start end dates or version numbers. Today, a very common pattern used by big companies like Facebook, Airbnb, they just snapshot entire dimension tables daily or weekly using table partitions. So if you want to know what a customer's address was last Tuesday, you just query the customer dimension partition for that date, want the current address, query today's partition. The rationale is blunt. Compute is cheap, storage is cheap, engineering time is expensive. Why build complex SCD logic when you can just keep full historical copies and let the powerful query engine handle filtering by date? It dramatically simplifies the ETL and the mental model for analysts.
Wow, okay. Just snapshot everything. That is simpler conceptually.
It often is. It leads to this core principle that really sums up the modern approach. Use technology to replace later whenever possible. If the cloud platform can brute force the calculation efficiently, maybe don't spend weeks of engineering time building a clever but brittle manual workaround. Even if it uses more compute cycles, the total cost of ownership might be lower.
And does that change how you approach modeling itself?
I think it encourages a more agile approach. Maybe model as and when you need to. Start by getting your raw or lightly cleaned data into the warehouse, like that bronze-silver layer. Let analysts query that directly first. Only invest the time in building formal dimensional models, like star schemas in the gold layer, or complex aggregates when the performance on the raw data becomes genuinely painful, or when specific reporting requirements demand that highly structured view. The flexibility of modern ELT transforming data inside the warehouse makes this iterative approach much more feasible than the old ETL world where changes were much harder.
Start simple, optimize when necessary, leveraging the platform's power. That feels like a really important takeaway. So, pulling it all together, whether you're building a classic warehouse, a lakehouse, going mesh, what are those universal best practices that ensure whatever you build actually delivers business value?
Right, because the tech is just the enabler. Success comes down to some core practices. First, always define clear business objectives. What specific problems are you trying to solve? What goals are you supporting? Your architecture must be aligned with the business strategy. Without that, you're just building tech.
Start with the why.
Absolutely. Second, adopt a scalable and modular design. Think about future growth from day one. Can it handle more data, more users? Is it built-in components so you can update or replace parts without ripping everything out? Modularity is key for long-term health.
Build for change.
Exactly.
Mm.
Third, never forget, prioritize data quality. We talked about this, but it bears repeating. Continuous cleansing, validation, monitoring, trustworthy data is everything. This needs ongoing effort.
Quality isn't a project, it's a process.
Well said. Fourth, implement strong data governance. Clear policies, ownership, stewardship, access control, things like role-based access control, RBAC, regular audits.
Yeah.
You need that framework for accountability and responsible data use.
The rule book again.
Yep. Fifth, leverage automation. Automate as much as you can. Data pipelines, testing, monitoring, maybe even some governance checks. Reduces errors, improves efficiency, frees up your smart people for harder problems.
Work smarter, not harder.
Right. Sixth, invest heavily in security. Encryption, access controls, vulnerability assessments, data breaches are catastrophic. Security has to be baked in, not bolted on.
Foundational security.
And finally, number 7, foster collaboration. This stuff isn't built in an IT silo. You need data teams, business stakeholders, IT infrastructure folks, all talking, cooperating. The best architectures meet diverse needs, and that only happens through collaboration.
Get everyone talking. Makes sense. And underlying all of this, as you mentioned, is this huge ecosystem of technologies, right? Databases, ETL, ELT tools, master data management, big data platforms like Spark or Flink, all the cloud services. It's a complex landscape.
It really is. Choosing the right tools for the job is part of the architectural process itself.
So we've definitely covered a lot of ground today. A real deep dive into data architecture, warehousing, moving from those basic definitions through the different architectural styles like lakes and lake houses, and even digging into how modeling itself is evolving with guys like Kimball and the rise of cloud power. You've really given us a map for how businesses can turn that raw data into something truly strategic.
Well, hopefully it's clearer now that an effective data architecture isn't just a technical thing tucked away in IT. It really is a foundational business asset. When done right, it ensures your data is trustworthy, it's accessible when and where it's needed, and it positions the organization to actually innovate and grow using data. It helps simplify, improve quality, and get those crucial insights.
So what does this all mean for you, our listener? Hopefully you now have a much stronger grasp of the key principles, the different approaches, and the best practices that really underpin any successful data strategy today, whether you're involved in building one, using one, or just trying to understand its impact.
And maybe a final thought to leave you with. As data keeps growing at this incredible pace, and AI keeps pushing new frontiers, what other kinds of hard work? You know, those manual data processes, those complex modeling steps that we used to think were absolutely essential, which of those might become optional, or maybe even completely obsolete? How will technology continue to reshape that fundamental trade-off between human effort and machine power when it comes to managing and understanding data?
That's a great question to ponder. A really dynamic field. We definitely encourage you to keep exploring, keep asking questions, and, well, keep diving deep.